Hi, this is Professor David Opterbeck. Welcome to the third lecture in our second module in the Cybersecurity and Computer Crime class. In this lecture, we will be looking in some more depth at the Computer Fraud and Abuse Act. So recall from our class last week that we talked about the basic structure of the Computer Fraud and Abuse Act, and we saw that there are a number of specific offenses which have predicates, and most of them, as a predicate, have access of a protected computer either without authorization or in excess of authorization. So we saw that this is largely an access-based statute. We looked at the definition of protected computer and saw that that definition is very broad. It will pretty much cover any computer or computer device that's connected to the internet. So a key question in many cases is going to be this question of authorization. Was access without authorization? Was access in excess of authorization? And in particular, this question of in excess of authorization has been a hot area for litigation, has been a hot area for potential legislative reform, and you've seen that in some of the cases that we read and that we will look at tonight. The first case that I asked you to read and that we'll talk about tonight is U.S. v. Morris. This case goes back to the very earliest days of the internet, and the Morris worm, in fact, is looked at as one of the triggers for this whole question of talking about cybersecurity. It was really the first large-scale, at the time, large-scale example of the vulnerability of the internet. I recall when this all happened in real time, and there was truly panic about the stability and structure of the internet. There was actually fear that that this event could have taken down the entire internet. That, of course, didn't ultimately happen, but it did expose, really in the public consciousness for the first time, the possibility that this network, which was thought to have been really quite robust and stable because of its kind of open source development, that in fact there were vulnerabilities in some core functions of the internet. Now, Morris was, at the time that this happened, a graduate student. The widespread belief, and what appears to be the fact, is that Morris wasn't doing this maliciously. He was actually doing this to try and test the vulnerabilities of the network. He didn't intend for it to have the result that it did have, but nevertheless it did have, again, at the time, a proportionally very significant result. And I think one of the things to think about is actually the relatively small size compared to today of the network when this actually happened. Now, instead of me trying to explain how this worm worked and what it was, I'm going to show you now a brief portion of a video that's part of a series of videos on this subject available on YouTube. So we're going to pause for a moment, and I'm going to show you this video, and then we'll come back and continue our lecture.
On the evening of November 3rd, 1988, approximately 25 years ago, a graduate student at Cornell University named Robert T. Morris Jr. executed a computer program that inadvertently caused a level of destruction across the internet that would ultimately make it one of the most historic events in the field of cybersecurity. In fact, one could even argue that up until this point, very few people had actually taken cybersecurity seriously, and that on the whole, cybersecurity hadn't really been viewed by many as a formal discipline within the broader field of computer science. After all, it's important to keep in mind that in 1988, very few people had even heard of the internet, let alone had any appreciation for the implications of securing it. And to be fair, the internet was very different in 1988. It was primarily used as a tool for academics to share information. The internet in 1988 wasn't really used for things like e-commerce or for online banking as it is today. And so there was a lot less motivation to actually secure the internet. The program that Robert Morris Jr. wrote has come to be referred to as the Morris worm, And I thought I would do a series of videos that describe the Morris worm, with this first video being maybe a bit more of an overview. Now, I do want to stress that the Morris worm is very much a historical relic at this point. The original Morris worm would not propagate or do as much damage today because the technical flaws that it took advantage of to propagate are no longer found on modern systems. Now, that being said, the Morris worm is extremely important from a historical perspective, and in many ways, it was a major impetus behind the development of cybersecurity as a formal field. It really served as a major wake-up call. As soon as the Morris worm would get onto a system on the internet, it would attempt to connect to and install itself on other hosts that were really connected to that first system. Now, under normal circumstances, it shouldn't really be possible for a computer program running on one system to gain unauthorized access to a different computer and install itself. However, the Morris worm took advantage of several technical vulnerabilities. In particular, the worm took advantage of technical vulnerabilities in 3 Unix programs, and these were, number 1, the sendmail program, the fingerd program, and also the rsh/rexec program. Now, in the case of the rexec, and to a certain degree in the case of RSH, the Morris worm was really taking advantage of the fact that many users choose simple passwords. And that was true especially 25 years ago. So the Morris worm included a module that tried to guess the passwords in order to gain unauthorized access to user accounts on a system. Now, in order to control the computational resources that were taken up by the worm, Robert Morris Jr. actually put in a very specific check that went like this. If a copy of the worm program arrived on a system that was already running a copy of the worm, then the programs would effectively flip a digital coin and one of them would self-destruct. The result of which is that only one copy of the worm would run on any one given system at any one moment in time. And so as such, the worm wouldn't take up too much in the way of system resources. However, Robert Morris Jr. decided to put in a small bit of code in his worm so that 1 out of every 7 times this self-destruction step would be skipped. And this one nuance, this seemingly tiny degree of replication, ended up making literally all the difference. Gradually, more and more copies of the worm started running on a given system, and these copies sucked up resources on that system. As the system got busier and busier, running more and more instances of the worm, it became less and less able to service regular requests, and basically the system became so bogged down that it was otherwise inoperable. At the time the worm was released, the internet comprised some 60,000 or so systems, and based on very, very loose estimates, over the course of about 2 days, from November 2nd to November 4th, 1988, about 10% of these systems, about 6,000 systems in total, actually crashed under the weight of being repeatedly infected with the Morris worm. Beyond the damage that was caused by multiple copies of the worm taking up system resources, no other parts of the worm, or the worm's code rather, exhibited any destructive behaviors. And the overall evidence seems to suggest that Morris was not motivated by malice. There clearly is a lot that Robert Morris could have done, given just how many systems the worm infected, and also the kind of access that he had. Rather, the evidence seems to suggest that Morris was driven by curiosity to conduct an experiment that really ended up going awry. Ultimately, Robert Morris Jr. was convicted on a single felony count of violating the Computer Fraud and Abuse Act of 1986. And he was actually the first person who was convicted in the United States under this act. His ultimate sentence after appeals was 3 years of probation, 400 hours of community service, and a $10,000 fine. Since that time, Robert Morris Jr. has gone on to have an illustrious career in technology. He completed his doctorate from Harvard. He went on to join the faculty of MIT, where he's actually now a tenured professor. He was a co-founder of ViaWeb, which was sold to Yahoo in 1998. And in 2005, Robert Morris Jr. was among the founding team of Y Combinator, which is a startup accelerator that is extremely well known in Silicon Valley. So that's what I wanted to say about the Morris worm in this video. In subsequent videos, I'll dive into some more details regarding the underlying mechanics and the architecture of the Morris worm.
Okay, welcome back to the lecture. And so as we've seen, the facts in the case involve this Morris worm, this graduate student who is trying to show some kind of proof of concept in terms of the inadequacy of computer security, of the security of the internet. He releases this, it spreads much faster than he thought it would, and it causes widespread damage to university computers and also to government computers. And recall from our internet governance module that at this time, or in the very early days of the internet is kind of a partnership between government and universities. So an effect on the network is going to have some effect on government computers as well as on university computers, and that's part of the reason that this case leads to a prosecution of Morris. So the video mentioned that at the end of all this, Morris got probation. It also mentioned, and if you look Morris up, if you Google Morris, you'll see that he indeed did become an early internet rock star and very, very preeminent in his field. So I suppose one thing that this case shows is that you, at least at one point in time, could be convicted of a CFAA violation and still become quite a star in the networking field. Okay, so what are some of the legal issues in this case? And like many, if not most of these cases, it really boils down to issues of statutory interpretation. Now you should note this language of the statute was a bit different when this case was decided than it is today. The statute has been amended a number of times, and I'll talk about some of those amendments in a moment. But the basic policy questions that underlie these interpretive issues are similar to ones that continue to bubble up today. So the first issue is the question of intent. Did the intent requirement in the statute apply only to the question of access, or did it also apply to the question of the intent to cause damage? Remember that Morris's story, which seems to be true, is that he did not intend to cause such widespread disruption and damage to the network. So if the intent requirement means you had to have specific intent to access and also specific intent to cause damage, then Morris is not culpable. So to resolve this question, the court looks very carefully at the language of the statute, and the court notes that the statute states that intentionally modifies access, intentionally access a federal interest computer. That language has changed a little. Now we say a protected computer, and thereby, through that access, causing loss. So in looking at that, the court says the language pretty clearly means that the intent relates only to the access, and therefore the fact that Morris didn't intend to cause the widespread loss and harm that he actually caused is really irrelevant so long as the loss that he caused exceeded the threshold, which it obviously did. The second question, and maybe one that's somewhat more interesting for our purposes of thinking through the policy of the statute even today, is the question of authorization. So Morris argued that his access, in fact, was not unauthorized. Morris said that as a graduate student at Cornell at the time, he had access to the internet, he had access to university computers, all of the programs and protocols that he was using, such as SendMail, he had access to. The issue was that the access that he gave him, that was given to him, combined with his knowledge of the network, enabled him to create something like this worm. So he argued basically that the statute doesn't criminalize the creation of a worm. It criminalizes unauthorized access, but his access to the network was authorized. And the court rejected this argument. And so you see here the court said, although Morris did have general access, the intent behind that access, the function that he was given, was not to create things like worms, but to do other things related to his academic work. And therefore, in fact, in sending the worm, he acted without authorization. So I mentioned that the statute has been changed a number of times, so let's take a look at some of those changes to the statute. The particular section A5 that was at issue in the Morris case has been amended several times, and the current version of it is A5 capital A, which is the malware portion of the statute, A5 capital B, which is intentional access recklessly causing damage, and A5 capital C, which is intentional access without authorization causing damage. So capital B and capital C there are most related to the previous version of the statute under which Morris was charged, and so there the focus of the intent is on the access, so access without authorization, and then the penalties will differ depending on whether the damage was caused recklessly or the damage was caused non-recklessly. Capital A is what I call the malware section of the statute. And if you look at the statute itself, it doesn't use the word malware, but if you look at the kinds of things the statute describes, it's the kinds of programs and things that we might think of as viruses and worms and so on. And notice here that this portion of the statute, the intent focuses on the causing of damage. So to some extent, some of these changes to the statute are designed to address the kinds of issues that were surfaced in the Morris case, and it's an effort to make the statute a bit broader and to make sure that it's covering the range of things that someone like Morris might argue that it shouldn't cover. We still have, though, this question of damage and intent to cause damage, and we always have a tension like this when you deal with a statute involving computer applications, programs, software, things like that, because they often have dual use. Sometimes the use can be malicious, sometimes the use can be non-malicious. Even something that's designed as a virus or a worm can be used by ethical hackers or white hats to do research, to test vulnerabilities, to try and improve security. So we always have to try and figure out how we're going to word a statute so it gets applied to cover what we want it to cover, but not to cover what we don't want it to cover. And you can sort of think about for yourself whether the wording of the statute is now doing the job that we would really want it to do. You might ask yourself, as you're reading the Morris case and you're seeing the focus is all on access without authorization and this question of intent, why not talk about access in excess of authorization under the current version of A2? Well, one of the reasons might be, one of the reasons is that the wording of the statute was a bit different back when the Morris worm was released. Even then, it was similar enough. Another reason might be that the Section A2 requires that some information be obtained. Now, recall last week you mentioned that really covers a wide range of things. Almost any time you visit a website, for example, you're getting some information back from the website that you're visiting. But a worm, and certainly in the very early days of the internet, a worm might be a rare case of gaining access without actually obtaining any information. You're sort of sending this thing out. It's not really giving anything back to you in a sense. It's just going out and propagating itself.